Welcome back. In the last part we went way over the head of what geocentrists can understand, with the startling revelation that trigonometry works at any distance despite the ignorant excuses put forward by geocentritards. We also saw how stellar aberration provides another means of confirming that Earth orbits the Sun, whilst allowing us to cross-check key properties of that orbit. In this part we'll see what else light has to say about the universe. An object at a given temperature emits electromagnetic radiation. A dense object emits across a broad range of frequencies. The hotter the object, the more light is emitted at all frequencies, so the object appears brighter. However, there is a wavelength of peak emission, and this also varies with temperature according to Wien's law. Thus, the colour of an object also varies with its temperature. The curves shown represent those of an idealised kind of object called a black body, which reflects none of the radiation that falls upon it. A black body doesn't necessarily look black because it can emit radiation, and the radiation emitted depends entirely on its temperature. As it happens, stars behave very nearly like black bodies. Here's the black body curve for a temperature of 5777 Kelvin, and here's the spectrum of light emitted by the Sun as measured above Earth's atmosphere. Using Wien's law, we can easily calculate the wavelength of maximum emission for a black body at a given temperature. For 5777 Kelvin, we get a wavelength of 502 nanometers. We can use the same law in reverse to determine the surface temperature of stars. Sirius, the brightest star in the sky, emits most of its radiation at 290 nanometers. This indicates a surface temperature of around 10,000 Kelvin. This high temperature is why stars like Sirius appear a blue-white rather than a yellow-white like our Sun. In 1802, William Wollaston was investigating the refractive powers of various substances. During his work he discovered dark lines in the Sun's spectrum when shone through a prism. He also found that candlelight produced distinct lines of colour. His findings were published in the Philosophical Transactions of the Royal Society of London, but he couldn't explain them. In 1814, Joseph von Fraunhofer repeated Newton's classic experiment of shining sunlight through a prism, but with a big difference. Using intense magnification, he discovered more than 600 dark lines in the sunlight spectrum. Today, more than 30,000 are known. Another German, Robert Bunsen, invented the Bunsen burner in 1857. It was already known that different elements gave off coloured light when sprinkled into flames. His colleague, Gustav Kirchhoff, suggested passing this light through a prism. They found distinct bright spectral lines. They quickly established that each element, and they worked their way through all the elements known at the time, has its own distinct pattern of spectral lines. By vaporizing samples of minerals, they discovered new elements, including cesium, named after its grey-blue light, and rubidium, after its red light. At this point we should probably remind ourselves of the total contribution to human knowledge made by geocentrists. The newfound ability to discover elements wasn't limited to Earth. The solar eclipse of 1868 saw the recognition of a spectral line from the Sun's chromosphere that did not correspond to any element yet tested on Earth. The new element was named helium and wouldn't be found on Earth until 1882. It's not just elements that have unique spectra, molecules do too. Whereas dense objects and black bodies emit light across a broad range of frequencies, elements and molecules emit or absorb light at specific frequencies. A relatively cool gas in front of a broad spectrum produces absorption lines in that spectrum. The absorption lines occur at the same wavelengths as the emission lines of the same gas. Thus, the dark absorption lines in the Sun spectrum tell us about the elements in the upper regions of the photosphere. 67 different elements are found, with the most abundant being hydrogen at 71% by mass and helium at 27.1% by mass. Above the photosphere and visible during a total eclipse is the chromosphere, a glowing pinkish layer of gas. Unlike the absorption spectra of the photosphere, the chromosphere produces an emission spectrum that reveals hydrogen, singly ionized calcium, ionized helium, and ionized metals. The hydrogen alpha emission at 656.3 nanometers is what gives the chromosphere its pink color. Above the chromosphere and about 1 millionth as bright is the corona. This can only be seen by blocking the light from the photosphere using a telescope with a coronagraph or a conveniently placed moon. During an eclipse, the corona can be seen with the naked eye, providing a view of its sheer size and the magnetic loops within it. Spectroscopy of the corona reveals its composition and temperature in excess of 2 million Kelvin. The corona was initially thought to contain elements not present on Earth, as unusual spectral lines are observed. Laboratory experiments on Earth, however, revealed that these lines are due to known elements in highly ionized states. A green line at 530.3 nanometers is due to iron atoms that have had half of their 26 electrons stripped by the intense temperature. Spectral analysis does present yet another problem for the feckless geocentritard. It reveals that the Sun and stars are all made of essentially the same stuff in very nearly the same proportions. The stars and our Sun are the same kind of object, with the same energy source, nuclear fusion. Of course, the reason all the other stars look like points of light is because they're so very far away. A simple concept that is also completely incompatible with Earth being the mysterious centre of the universe, for reasons we've already seen. Geocentrists, however, are unperturbed by such things as reality. The most insane subscribers to this outdated twaddle attempt to get around the scale of space by claiming that the Sun is smaller and closer to Earth than we are told. We established in Supplement 1 that this is nonsense using just a few measurements no geocentrist has bothered to do in the last 340 years, whilst they sit there whining like little brats about how everyone else's must be wrong for reasons they can't articulate, let alone substantiate. If the Sun and stars are closer than we're told, then geocentrists need a viable physics model to explain what they are, how they shine, why some have been observed in human history to die by undergoing catastrophic explosions, why many exist as binary star systems that can be observed to orbit a common centre of mass, what the objects are that light up the other galaxies if they're not stars, and what all the clouds of dust and gas are for. Did their sky fairy forget to clear up after making the universe? Since the stars aren't lights placed in a dome rotating round Earth by a magic sky fairy, the simple facts about the nature of the Sun and stars lead us inexorably to the simple conclusion that the Sun really is a star, and like the rest of the universe, has no physical means of orbiting the Earth. Which of course means that geocentrism is bollocks. We know that electromagnetic radiation is subject to the Doppler effect. It was confirmed experimentally for light in 1900 by Aristarch Belopolsky using a setup of rotating mirrors. For all electromagnetic radiation, the Doppler effect simply results in a change of its wavelength and frequency. In the case of visible light, this translates to a tiny change in colour. If the light source is moving away from you, or you move away from it, the wavelength increases. If moving towards you, it does the opposite. The shift in wavelength of light from stars caused by the Doppler effect shouldn't be confused with cosmological redshift, which is observed over much larger scales. That is caused by the expansion of space itself. The Doppler effect allows us to determine whether stars are moving toward or away from our solar system. This had been done as early as 1868 by Sir William Huggins. Measuring Doppler shift allows the speed along the line of sight to be determined. This is the radial velocity. Stars, as we've seen, behave like black bodies and emit electromagnetic radiation at a broad range of frequencies. To identify Doppler shift then, markers are needed. Fortunately, such markers in the spectra exist, the absorption lines. Since Earth is orbiting the Sun, we should expect to observe a variation in the wavelength shift for stars throughout the year. When Earth is heading towards a star, we should see the greatest blue shift or smallest red shift, and when heading away from it, the greatest red shift or smallest blue shift, with intermediate measurements in between. This pattern should then repeat on an annual basis. And it does. This was observed in 1887 by Hermann Vogel and Julius Scheiner. What explanation could geocentrism possibly offer to explain this observation? Well, the geocentrist now needs his entire universe to have another layer of motion on top of those we've already seen. What their universe now requires is that the entire cosmos also vary its distance from Earth once a year by around 300 million kilometers, just to create the illusion of Earth orbiting the barycenter of the solar system with a major axis of, coincidentally, about 300 million kilometers. If you're the kind who thinks the most complex solution is probably right, then that might sound feasible to you. And of course, if the entire universe apart from the Sun and inner solar system is cycling around Earth in a 300 million kilometer wide circle, when is Earth at the centre of that universe? The centre is a meaningless concept, and geocentrism is nonsense by default. Vogel and Scheiner were able to discover the wavelength shift induced by Earth's motion because Earth isn't the static centre of the universe, and the raw consequence of that fact is that geocentrism continues to be bollocks. Naturally, stars don't just move towards or away from us, so there is also a component of motion perpendicular to our line of sight. This is the tangential velocity and can be derived from the proper motion of a star and its distance. Proper motion is the angular change in position of a star and was discovered by Edmund Halley in 1718. Barnard's star has a proper motion across the sky of 10.358 arcseconds per year. Over the course of a human lifetime, it can easily be measured to move against other background stars. Using this simple formula, we can find the tangential velocity of a star. Mu is the proper motion in arcseconds per year, and d is the distance to the star in parsecs. Barnard's star is 1.83 parsecs away, and we know its proper motion, so this gives us a tangential velocity of 89.8 kilometers per second. What about its radial velocity? To calculate the radial velocity of a star, we take the change in wavelength of an absorption line over its known wavelength from the laboratory where there is no Doppler shift, and multiply by the speed of light. A spectral line of iron measured in the light from Barnard's star has a wavelength of 516.445 nanometers. The same spectral line on Earth has a wavelength of 516.629 nanometers. Plug in these numbers and the radial velocity of Barnard's star is minus 107 kilometers per second. The negative sign is a consequence of blue shift, thus the star is moving towards us. By combining the tangential and radial velocities using simple Pythagoras theorem, the space velocity of a star can be calculated relative to the Sun. We find that the space velocity of Barnard's star is 140 kilometers per second. What can we conclude from this? The stars are not fixed, and have their own motions through space. Of course, these motions are another layer of motion on top of all the other layers of motion that the geocentric universe would need to undergo to produce the perfect illusion of a universe that isn't geocentric at all. And then there are the binary systems, such as Sirius. The faint white dwarf star Sirius B orbits the much more massive Sirius A, with a period of 50 years. This is what we'd expect, because after all, the idea that larger masses orbit smaller masses is both physics-defying and childish. Nowhere in our galaxy is the motion of stars more pronounced than at its core. Here, individual stars are seen to orbit an unseen object in readily observable time spans. The fastest orbit is just 11.5 years for the star S0102. Another star has also had a complete orbit observed, S02, at 15.56 plus or minus 0.35 years. Its position has been monitored since 1995 by astronomers at UCLA and the Max Planck Institute for Extraterrestrial Physics. There are two candidates for what could cause stars to orbit each other and to move in such fast orbits at the centre of the Milky Way. We would love it to be Mr. Space Hammerman, but sadly this is not his moment either. Surely there must be some kind of universal force that acts on masses at a distance.
Gravity, you f***ing retard! Gravity!
And the only object with enough mass to fling stars around in such short and fast orbits is a supermassive black hole. Unfortunately, geocentrists have no explanation for why such an object exists, why everything in the galaxy orbits the core, and why stars in every other galaxy in the universe orbit the centre of mass of their host galaxy, or why galaxies orbit each other. The failure of geocentrism to have any explanatory, predictive, or practical use remains total. This is as we expect, because it's total bollocks. They have no valid physics to explain why the rest of the universe is driven by gravity, or why gravity works on Earth, but with the special exemption when it comes to orbiting the Sun. Any universe that requires such a specific exemption from the laws of physics that apply everywhere else is clearly not grounded in reality. In Part 8 we'll see what else light can reveal about the universe, and what lumps of rock and metal can tell us about Earth's place in it. See you then.